Welcome to today's lesson. Today we are going to continue looking at systematic listing. Our first question says Tony has 5 shirts and 3 pairs of jeans. How many different outfits does she have? This question is slightly different to our questions from last lesson because we're not being asked to list all of the combinations. We just need to know how many combinations there are in total. Now, we could write down 5 different shirt names and 3 different pairs of jeans and then try to combine these together. However, that's going to take too long. So instead, we have a better method. If we think of the first shirt that Tony has, with that shirt she has 3 different combinations. That's because she has 3 different pairs of jeans to wear with shirt number 1. With shirt number 2, she also has 3 more combinations because of the 3 pairs of jeans. This is the same for shirt number 3, shirt number 4 and shirt number 5. So if each shirt has 3 different combinations and there are 5 shirts in total, we can do a calculation to work out how many combinations there are in total. If each of the 5 shirts have 3 combinations, if we multiply 5 by 3, that will tell us the total combinations. Therefore, for this question, there are 15 different combinations of shirts and jeans that Tony can wear. On to the next question. A shop sells a meal deal. You can choose from 5 different sandwich fillings, 4 different crisp flavours and 5 different drinks. How many different combinations are there? Just like the last question, we can work out the total amount of combinations by multiplying the different amount of choices at each stage of the problem. In the first part of the problem, there are 5 different sandwich fillings. Then we have to choose from 4 different crisp flavours, and then we have to choose from 5 different drinks. If we multiply these together, that will tell us how many combinations there are in total. To multiply 3 numbers together, we'll start by multiplying the first 2 numbers together. 5 times 4 is 20. The times 5 will drop down, as we've not used the times 5 at the end of the question. 20 times 5 then gives us the answer of 100 combinations in total for this question. On to our next question. How many 4-digit numbers can be made from the digits 1, 2, 3 and 4 if numbers can be repeated? So here we have a 4-digit number. Now, I'm not going to list all of the different combinations and count them up because again, this will take too long. We just need to know how many numbers there are in total. So to do this, for each digit, I need to consider how many options we have. Well, the first digit could be 1, 2, 3 or 4. The next digit could be 1, 2, 3 or 4 because digits can be repeated. For the next one we could get 1, 2, 3 or 4, and the last digit could also be 1, 2, 3 or 4. So how many choices do I have at each stage? Well, there's 4 choices here, 4 choices here, 4 choices here, and 4 choices at the end. So we need to multiply these 4s together to work out how many combinations we have in total. To do this multiplication, we will make it slightly easier for ourselves by pairing off the 4s together. So this 4 times 4 is 16, and this 4 times 4 is 16. So we just need to multiply 16 by 16 to work that out. If we use a Napier method to do our multiplication, 16 times 16 gives us the final answer of 256 combinations. And now on to today's final question. How many 3-digit even numbers can be made from the digits 2, 3, 6, 8 and 9 if numbers can be repeated? Here, because we have a 3-digit number, I'm going to write in the space for 3 digits, and we're considering how many choices I have at each stage. For the first digit, we have the choice of 2, 3, 6, 8 and 9. For the second digit, we have exactly the same choices. But for the last digit, we don't have 5 choices. This is because the overall number needs to be even. Even numbers end in 0, 2, 4, 6 or 8. So out of the digits that we can choose from, we can only have 2, 6 or 8. So for the first digit we have 5 choices, for the second digit we have 5 choices, and for the third digit we have 3 choices. We need to multiply these numbers together to work out how many choices we have altogether. 5 times 5 is 25. The times by 3 will drop down because we've not used it. And 25 times 3 tells us that there are 75 3-digit even numbers that can be made out of those 5 digits. And that concludes today's lesson on systematic listing.